have the function notation y is equal to the f of x. So whenever you see that thingy, the f parenthesis x, never ever read f parenthesis x or fx or f times x. That is a special notation for function. We read that f of x. The input is x, and the output would be the f of x. So whenever we want to evaluate a function value, just like the first one, if I have the f of x equals to 2x plus 3, when I want to evaluate the f of 4, we would simply replace the x by 4 and substitute x equal to 4 and then simplify. Now the very first step usually is not a problem, but the challenge comes from the next when we try to simplify that. Unfortunately, a lot of time students make careless mistake dealing with the order of operation. So we also try out this one. And now let's take a look at something interesting. If I have f of x equals to 4x squared plus 5x, and I want to find the f of x plus h minus the f of x, and then the whole thing divided by h. So how can I handle that? Well, first thing, I need to know what is the f of x plus h. What is the f of x plus h? What's that thingy? What's that mean? That is a function notation, yes? We are looking for the f of x plus h. What is the input in this case? Yes? That's not the input. X plus h. The input is whatever inside the parenthesis. That is the input. So when we compare the previous problem, if I have f of x equals to blah, 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 and now I want to find the f of a, then what do? I simply identify what is the new input. In this case would be a. So I'm going to replace all the x by what? By a, by the new input. So if I want to find the f of x plus h, I am going to, well, let me just write it down here. Write down the whole thing. The whole thing divided by h. I am going to replace the x by x plus h. So I have 4 times parenthesis x plus h square plus 5 times no longer x but x plus h. Let me put a bracket around them so that we can identify easily, oh, that thing is the f of x plus h. And then minus the f of x. So I have minus the f of x, which is 4x squared plus 5x. And then the whole thing divided by h. Is that right? I made some mistake here. Can you identify what is the problem? I need a parenthesis around the f of x. The first parenthesis is actually insignificant, but the second parenthesis is a must. If you don't have that, then that would be a problem because you are minus the whole thing, the whole f of x. So you do need to have a parenthesis. And then afterward, we simplify that. Now again, the simplification sometimes is the challenge for some of the student. And if you find out that, hey, you don't feel comfortable, then work on that and find out where is the problem. So master this, and then from that point on, and you will feel good whenever you see a function problems like this. I expand the x plus h square, and then after that, let's distribute the 4 and distribute the 5. So I got 4x squared plus axh plus 4h squared plus distribute the 5. So we got 5x plus 5h. Simultaneously, I remove the bracket. Can I remove the second bracket? Just simply wipe it off. Can I do that? What do I need to do? Whenever you minus a polynomial, you have to change sign when you remove the parentheses. So that would becomes 4x squared minus 5x. Now, if you don't remember that, put down a note. Help yourself to remember whenever you minus a parenthesis, when you remove that parenthesis, you need to change sign. That is why from the very beginning, we cannot just put down minus 4x squared plus 5x. We must have a bracket. And then the whole thing divided by h. Further simplify that. Any things we can cancel out? 4x squared. Cancel out the 4x squared. Anything else? 5x. 5x minus 5x. And after that, I got the 8xh plus 4h squared plus 5h, and then divided by h. Can I cancel out the h? Can I cancel out the h here like that? We cannot, because we have a plus or minus on the top. This the whole thing divided by h. So what we need to do is we need to factor out the h. And now, can I cancel out the h? Yes, because it becomes h times something. So I can cancel out that. So finally, it will become ax plus 4h plus 5. All right, let's take a look at the next page. There's something wrong with the screen, right? I apologize for that. I don't see that from my side. So there's something wrong with the projector, maybe. Okay, let's take a look at the piecewise defined function. What is a piecewise defined function? Piecewise defined function is a function which follows a different formula for the different parts of the domain. For example, we have f of x equals to 4 if x is less than or equal to 0. It's between 0 and 2 and including the 2. Then the function will follow another formula, 4 minus x squared. And when x is bigger than 2, then the f of x will be equals to 2x minus 6. In a different x, we will follow a different formula. Now, but note that there is only one formula. There is only one function. A lot of time we have situation like that. For example, like your pay scale. At the very beginning, you are in probation and for maybe a month, and after a month, and you will entitled to some sort of benefit, maybe the health benefits, maybe a years later, and you are entitled to the pension, and you also get a pay raise. Now, all of these are one function, one big pay scale, but in a different x. different time, and you will follow a different formula. And that's what we call the piecewise divide function. Now let's see if we can graph out this particular function, and let's see how it looks like. Well, take a look at the graph. When we have the first formula, y is equals to 4. So how does it look like? Y equals to 4. Anybody remember? If I want to graph out y equals to 4, what would that be? That's something that from the previous course. Y equals to 4 is a straight line. What kind of straight line would that be? That would be a horizontal straight line. Okay. Now you forgot about this, then your dancing shoe will become quite helpful. You quickly check it out and then see y equal to 4 and how does it look like. But of course, you should remember that. So maybe you forgot that, put a note over there and ask yourself to remind, hey, I need to refresh my memory. And how do I graph something, a simple curve, or using your dancing shoe to handle that. The next one, y is equal to 4 minus x squared. Y equal x squared, that's a problem. Y equal to negative x squared, so we flip it upside down. Plus 4, everything will raise up 4 units. So turn out, we have another one going like this. It should be going this way. This is 4, right? That is. And then y equals to 2x minus 6. So we have y equal to 2x is a line passing through the origin, and then minus 6. So it would turn out to be something go like this. This would be negative 6. Now, however, we are not going to need all of these. Let's take a look at the piecewise divide function again. Y is equal to 4. Under what situation? When x is less than or equal to 0. So we are not going to need the whole piece. We are going to wipe off that part. Okay. Now this is just the draft. Right? Later on, you need to redraw the whole thing. But we wipe off the right side of the y equal to 4 because we only use it when x is less than or equal to 0. The next one, the parabola. When do we need that? When x is between 0 and 2. So that piece, I don't want it. And 0 to 2. So this would be 0 to 2. And this piece, I don't want that. And the last formula, when x is greater than 2, we will follow the last one. So once I do that, I'm going to wipe off this. Now, so put all this together. How does it look like? Y equals to 4. We only want when it is like this. And then after that, we follow a parabola. So go down like this, all the way to here. And then when x is bigger than 2, we will follow another piece going this way. And all these things together is y equals to f of x. And that is how that particular piecewise defined function looks like. Can we evaluate the following? F of negative 3. When x is equals to negative 3, what would be the output? When x is equal to negative 3, what would be the output? X is equal to negative 3, y is equal to what? Sorry, I didn't hear what you said. When x is equal to negative 3, y would be equals to 4. We use the first formula. Why do we use the first formula? Yes. Why do we use the first formula? Because the input is negative 3, which is less than or equal to 0. So we follow the first one. What about the f of 7? It would be, which formula do we use? The third one. We use the third one. 2 times 7 minus 6. That gives you 8. We are using the third formula. Because x is equal to 7 now, which is greater than 2. How about f of 0? That would be 4. Which formula to use? The first one. Why we use the first one? Because x is equal to 0. So we use the first piece. How about the last one, f of 2? X is equals to 2. So which one, which formula we should use? Which one? That is the second formula, right? Because x is equals to 2. So we got the 4 minus 2 squared. So that would give you 0. I have another piecewise defined function. F of x is equal to 6x minus 1 if x is less than 0. And 7x plus 3 if x is greater than or equals to 2. Let's try to evaluate this 4. Okay. F of negative 3. Which formula we should use? We should use the first one. So we have 6 times negative 3 minus 1. So that would give me negative 19. What about f of 0? When x is equal to 0, which formula we should use? Which one? The second one. Should we use the second? We use the second when x is greater than or equals to 2. How about the first one? We would use it when x is less than 0. But now x is equal to 0. So which one I should use? None of them. Because this is undefined. In the function, they didn't tell us which formula. They did not define which formula to use when x is equal to 0. That's interesting. F of 4, I should use the second one. So that would give me 31. How about the f of negative 100 plus f of 100? Would that mean it would be f of 0, which is undefined? right? I add them up, 100, negative 100 plus 100 is 0. Should I do it like this, the lady? We can use both, can we? Why should we use both? For the first one, what is the input? Negative 100. When x is equal to negative 100, which one we should use? The first one, right? The second one, what is the input? 100. When x is equal to 100, which one we should use? The second one. So yes, in this case, we are going to use both of them. So let's see what happened. Plug in x equal to negative 100. And that will be the very first one plus plug in x equals to 100 into the second one, and we will have this, right? And then the rest would be the algebra. What would that becomes? 102. Now maybe think a little. Using the built-in calculator is even faster rather than you press it in your dancing shoe. Negative 600 plus 700 would be what? 100. Negative 1 plus 3, 2. So it's 102. Instead of thinking about, okay, negative 600 minus 1, what would that be? And then plus 700, what would that be? And then plus 3. That would take a much longer time. All right, last page. The domain and the range of a function. Okay, the domain of a function is the set of all values of the independent variable for which the function is defined, and the range of the function is the set of all values of the dependent variable. In another word, the domain is simply all possible input, while the range is the all possible output. Now, very often at the beginning, when we talk about function, we use y is equal to the f of x. So the domain is talking about all possible x values, and the range would be all possible y values. Now, remember the whole sentence. Don't just remember parts of it. Sometimes people will say, oh, the domain is x, the range is y. Well, it's not exactly x and y. It's the all possible x values. Okay? The range is the all possible y values. So you are not just going to mention one of the possible values. You need to describe all of them. Let's take a look at the very first one. If I want to find the domain and range, what would that be? Now, when we come to the domain and range, sometimes it's not easy because you really need to have a clear mind. You think about, hey, what kind of x I can plug in to this formula? Can x be positive? Can I plug in a positive x value? Yes. Can I plug in a 0 value for x? X can be 0. Can I plug in a negative x value? Yes. So what happened is the domain indeed, oh, sorry, is open parenthesis from negative infinity all the way to positive infinity. Now this is what we call the set notation. That means x can be anything. But how about the range? Can the y turn out to be anything? Well, we need to know some facts. X squared is greater than or equal to 0. But my goal is to get this. So how can I do that? I add 3 on both sides. So in another word, y is greater than or equals to 3. No matter what x would be, y is always greater than or equals to 3. So when I put it in the set notation, I will put it down like this, using an open bracket. That means it's including the 3. How about the next one? Y is equals to radical x minus 5. Yes? For the x, for the domain, well, you have to think about what could be the x value. The x can be anything in this case. You can plug in any x value, isn't it? You can plug in a positive x value, no matter how big or no matter how small. You can plug in x equal to 0, right? And you can also plug in x equal to a negative number. -1, -2, -100, -1,000, -1,billion. So x turns out can be anything, you know. Now, so sometimes think about the domain and range. It's a little bit interesting because it really require you to think a lot, all different kind of possibility. How about y equals to the radical x minus 5? Can x be anything this time? Then we need to know something else. Whenever we got the radical a right away, we know that whatever inside the radical must be what? Must be positive. It cannot have a negative inside the radical. So that means x minus 5 would be greater than or equal to 0. So in another word, x is greater than or equals to 5. So what happened to the domain? The domain would be from 5 all the way to positive infinity. How about the range? What is the possible x value? Then we need to know another thing. Whenever we got the radical a, that implies the radical a would be greater than or equal to 0. So if we know that, then that means the range would be like this. Now, both of these, another way to look at that is you could take a look at graphs. For the first one, when you graph it out, it would be a parabola go like this. So it's getting so bad. Oh, better? Okay, good. And you can see that this is a parabola, right? Doesn't matter what x would be, you can always find a y value. But at the same time, the y cannot be something below the vertex. So the y must be greater than or equal to 3. So another way to look at that is when you're using your dancing shoe to graph it out, and then you can also tell, oh, the y must be greater than or equals to 3. And for the second one, when we graph it out, it would be something go like this. is half of the parabola. Open to the right. Mhm. All right. So far so good. Right. Let's see another one. Y is equal to 1 over 2x minus 7. Can x be anything this time? When you have a fraction, we need to know something. The denominator cannot be what? Cannot be 0. So that probably would be the exception. The denominator cannot be 0. So let's see what would that be. I add 7 on both sides and divide both sides by 2. So I got x cannot be 7 over 2. So when I write the domain, that would be from negative infinity all the way to 7 over 2, and but close the parenthesis, union from 7 over 2 all the way to positive infinity. Now that is a little bit interesting notation. That is indeed talking about everything except the 7 over 2. All right, so far so good. All right, let us stop here for that section.